gone through only half, Jalaj. Completely didn't know. I just came today only back. So Jalaj, you're covering only about the SCD2, right?
Yeah, this is actually 2 only that we are going to cover.
Okay. So yeah, I have an idea on SCD2 type 2. So I implemented in my projects also, but not on AWS. So I think we didn't do it practically, right? How to implement on this one.
Yeah, that's exactly what we're going to do.
Okay.
So just to give you a recap, I mean, in detail, you can go through the recordings.
Yeah, sure.
So you know the context that what we are trying to do. We are going to have a data set and we are going to perform SCD2 logic here. Meanwhile, also taking care of connecting with Redshift, uploading data into Redshift, running queries on the Redshift, and connecting DynamoDB, sending emails when the pipeline is completed, and these kind of things we are going to do here.
Oh, okay. So we are adding the email also.
Yeah. So this is as usual importing the libraries. I'll explain if some different libraries is here as and when we are using those things. And then we had made some variables to locations of the files, like from where we are going to read, from where we are going to write, from where we are going to use the the previous data to store, and some other variables. In this phase, I am reading the data and creating a dynamic frame. In line number 51 to 52, I am creating an unload query and going to execute this query on Redshift cluster. And eventually this query is going to get executed on line number 54, where I call unloaded a Redshift from my functions. And here I have defined this function. So all these things actually I have explained in the last session. So in detail, it's actually quite in good detail. So you can go through that. Okay. And from this point, we are going to get started with our next things. Okay. Yeah, Shweta is going to join. Let's just wait for her.
Yeah. So Jalaja, before that I had some doubt, like a basic doubt. So when you say that SCD type, right? So it's like updating the existing accounts and creating a new row for the same account or whatever it is. Okay, so how here we'll be doing, like we are going to update, we write like an Oracle or Teradata like update statement we are going to write and insert the new records, or it's completed, since it's a file, we are just going to delete the existing files and created a new file.
This is a bit different than your oracles and those things. Okay. So it's actually completely different approach and implementation. So we will discuss that.
Okay. So we are yet to discuss, right? Then fine.
Yes, that is pending.
Okay. And also it's same, like Redshift and Snowflake, both queries are same only, right? Like what are the operations we do?
Queries are going to be different. So Snowflake is a different way of connecting that I have shown already to you.
No, connection is different. Yeah, connection I understand. Logic wise, I'm asking.
Logic wise, actually Snowflake supports update. I mean, see, this approach is also going to be different. Logic is a different thing. Approach is also going to be different because in Redshift, how do I explain this to you? It is actually different. Approaches are different on Redshift and Snowflake. Redshift, we are not writing these queries. We cannot, take the data frame and update on the Redshift directly. But on Snowflake, actually, we can do that kind of work. So it's a different approaches here.
Okay, so it has a different thing. So it's not we can't do the same common things in Redshift.
No, you can do, but that will not be a better way on Snowflake.
Okay, got it.
Okay, she's here. Okay, so from today, we are going to get started with our SCD2 logic. Okay, so in the previous classes, we discussed the approach, we discussed the context, and we discussed how we unload the data from Redshift to a common location that is going to be Airbnb previous. Okay. Now my actual logic starts from here. I mean, just for a reference, I have done a simple transformation here that I have created one more column that is new price. Okay. And I have, simply replace the dollars with a dollar sign. And this is example, like this sort of thing will be replaced like this. Okay. What I'm doing here, I mean, what's the reference here is all the transformations and all the logics that you would like to do in this in your actual code, okay, that you are going to be do before the SCD2 logic starts in this sort of format. Okay, see one thing, when you are going to actually work in the AWS projects like data engineering projects, you might not have the same structure, same codes. Okay, approach, codes, and the way of coding might be completely different. Even tools can be different. Okay, but this project, if you can understand this, okay, then you can land in that job. Okay, this is going to help you land in that job. Okay, see why I'm telling you this, because I do not want you to get confused at any place in the interview. So all your transformations are going to be happen before your SCD2 happens. Okay, just understand that part. Then our main logic starts. So as you asked Karthik, in AWS, okay, we do not have any SCD2 direct logics like that we have in MySQLs, Oracles, those okay, like where we can write an update query and we can say when matched do this, when not matched insert the rows. That sort of functionality is actually not here because we are not working with databases. Okay, our program, if you see it a bit carefully, this is only going to work on AWS Glue and Reds S3. Okay, with the help of Redshift, we are only unloading data and we are only going to load the data. Okay, only two operations we are doing, load and unload. We are not directly executing a query directly on Redshift. Okay, so we are not working with actual database or data warehouse here. We are working with object level storage, that is S3, and S3 does not support any select queries or update queries. Okay, so we'll have to figure out a way smartly to do that part. Okay, so how I am doing is I unload my data. Okay, if you see here, I unload my data using the unload function here, and that is going to be unloaded at this location. And from this location, I create a dynamic frame, the data source 1, and then I create a dynamic data frame like Spark data frame. I convert that dynamic frame to Spark data frame and call it previous DF. Okay, previous DF is nothing but your data that is already existing on your Redshift tables. Okay, then what I do, I am simply taking the length. Okay, I do a take function. Okay, take basically takes the data from data frame and tries to print that. So I'm simply saying take one. I'm trying to take one record from this data frame and I'm checking its length, the length of data frame. Okay, here length is going to give you how many rows you have in the data frame, and I'm only trying to take one. So basically, if I had even a single row in my Redshift table, that would have been unloaded onto this previous location path and it would appear here. Okay, and my length will be 1. Okay, but if I have no data at all, okay, if I have like this is the first time I'm going to upload data into my Redshift table, that means there's no data at all on the Redshift cluster. In that case, my if condition will be satisfied. Okay, my if condition that length of previous TF take 1 is equal to 0. That means we have absolutely no data in our tables. That means we are not going to perform SCD2. We are simply going to load the data. Okay, to perform the SCD2 logic, we should have the data with us. Okay, only in that case we can make the comparisons. But till now, at this point, we have no data. Okay. When the length is 1, that means we have no data found at the previous location, and we are going to simply go ahead and assign some meta information to that data that we actually had discussed in the last session. Okay. So what are those details? First one is surrogate key. I'm not sure whether I have that file with me. I think I have already modified that. Okay, it's not there. But if you remember from that class, we have surrogate keys, those dates, all those things we have actually discussed. Okay, so first column that we want to generate is surrogate key. What is surrogate key? Surrogate key is nothing but a unique number assigned to a particular record in a sequential way. Okay, that is what surrogate keys definition says. So in Spark, actually, we do not have a function that generates a sequential number to your records. I mean, let's open this file. It will be easier to explain with examples. So let's say I would like to generate a surrogate key column here. Like this, okay. This will have this data 1, 2, 3, 4, 5, and obviously, till the very end. So all the records are going to get assigned a surrogate key, okay. Then we will have date, when this record got loaded or updated, and we will have active flag. Okay. So now to generate this sort of sequential orders, in Spark we do not have any direct function. So what we are doing here is I use this function called monotonically increasing ID. Okay, if you see its definition on the Google, this says it's going to generate a number. Okay, but it is not going to generate in a sequential order. Okay, it's not going to be consecutive. It can be something like this. It's actually going to be something like this. Okay, so it's something going to be like, let's say 34 here, 44, 56 here, something like this. Okay, so it will be in sequential order, in increasing order as well, but it will not be a proper sequence. So to generate this sequence from this order, what we are doing, first of all, we generate a IDX column. Using the with column, I'm generating a IDX column. Logic is monotonically increasing ID. Then I create a window. This W here is, if you see in my import statements, I'm using window function as W. Okay, it is a SQL window function that we have normally seen. I'm creating a window over my data, I'm ordering it by IDX. Then on that order, on that window spec, I'm saving this logic in my window spec variable. I assign a row number. So if you have worked with SQL, so this is like generate row number, partition by this column, order by that column, and generate a row number. Same sort of thing we are doing here on our IDX column. And this is going to give me a surrogate key column in a sequential order. And now, as we do not want this IDX column anymore, okay, because this column is not required, it is just there for referencing purpose, I would like to delete this. Hence, I am calling drop function of PySpark data frames to drop that column. Okay, so this is the logic to generate surrogate keys. Okay, then as I mentioned, we want load timestamp to be generated. So I'm simply using Python's datetime.now function to create a timestamp object. Then I say .date. It's going to convert the timestamp into a date function. Okay, and I'm going to save it in LD timestamp variable. Understand, this is a Python line. It is not a PySpark line. This is something I know it's going to confuse you guys. But if we are not referencing a data frame, more or less it is a Python function, and we can mix code like this. Whichever suits you better, whichever is feasible for your logic, or it is easier for you to write, you can use that. Okay. We could have generated this load timestamp using the PySpark functions as well, but now I have simply used the Python function, and in my source data frame, I'm simply saying with column and creating a column called load time, and using the LD timestamp, I'm litting this. I hope you remember the lit function. It adds the same value on all the rows. So all the records which got loaded on day 1 will have the same timestamp, and that is exactly what we want. Okay. Likewise, as this is a first time load, okay, as this is a first time load, we had no data at a previous. That means all the records that are present in our file are basically new records. Okay, and all those records are active records. That's why I want to create an active indicator column, and I will keep my lit function on Y. That means I am going to say that all the records are active records and going to add this column into my source data frame. So in this part of code, we are adding 3 columns: surrogate key, load time, and active indicator. Do not get confused. IDX is something that we are using and dropping. Okay. Then I'm simply printing the schema and getting the source count at how many records I'm actually loading into my table. Okay. And then I'm going to write and load the data. So I'll just pause here. I'll explain this later. So if you have any questions still here, you can let me know. Take your time, go through the code. Just allow me a second now. Actually, my cluster is paused, so I just start that so we can run this code. Just allow me a minute. I will start that thing.
Jalaj, this data source, right? You are reading a source, right? Where is it?
This is a source. It is from S3 location.
Oh, you are reading a file. It's file only, right?
Yeah, it's a file only.
Okay.
Just a variable name is data source. That's all.
Yeah, I understand that. So we can't directly write a query and carry the data frame.
Come again. Yeah, you can convert this into SQL query as well using SQL context.
No. This is for Redshift to Redshift SCD only, right? So I'm asking it's existing table already in Redshift. So why can't I just write a query from the Redshift table and create a data frame instead of reading a file?
Then how will you do transformations there?
Okay, so in table we can't do then. We need to read only the files.
No. See, you are saying you can write this logic into a Redshift as well. Okay.
No, I'm asking. The source is already in Redshift, right? So I'm asking.
No, it is not on Redshift. Source is not on Redshift. Source is on your files. It is S3 files in CSV format.
Okay.
Redshift is your target.
Okay. Suppose you see, I have customer details. Okay, so I have some customer details which is available in Redshift. So I need to do a SCD on if any customer details like address changes, I need to update on top of it. So in that case, if I can read directly from a Redshift table, right? Select start from the customer table and create this data frame.
Yeah, but that's the question. How your source data is reaching into Redshift?
First time we'll be doing a normal increment, right? First time itself we won't do a CD, right? A CD after any updates.
But how your data is going to be there in Redshift? You are going to be uploading it from somewhere now.
Okay.
That is the same thing that we are doing.
No, I understand the thing, but I'm asking whether this scenario will be there. Suppose in a Redshift the data is there.
Chances are very rare. See, your source is never going to be Redshift. Okay.
Okay.
Because Redshift is not OLTPs. Here, your data is not being generated or modified. You're always going to extract data from source systems. That can be your SQLs, DB2s, some file systems. From those, from that places, you're going to extract the data and load it onto S3 buckets. Okay, that is your raw data. Then you are going to use the data and maybe doing some transformations, as I explained on line number 67. That is the place before SCD logic. You're going to do all those transformations, calculations, changes, dropping, selecting whatever you want. After that, if you want to have SCD to logic, that is you're going to convert. And once that is done, you're going to push the data into Redshift or tables. This is the sequence. Raw on S3, logic on ETL logic on AWS Glue, target on Redshift.
Okay. Okay, suppose I'll come in anyway. So we did it this one time. Okay, so I'm just loading my target in Redshift. So again on this target table, using the target table as a source, I got a new updated file. So again, I need to run this SCD type 2. So how do I do it then?
That is what exactly we are doing now. We unload our data from that table into a file.
Okay.
I mean, if you go, I mean, you're actually missing a session. That's why you have these questions. If you go through that recording, I have explained you this thing. See, there are two ways to connect with Redshift cluster. Okay. Either you can use a Spark's JDBC connection, and upload the Spark drives and all those things. But that is going to cost you because
you mentioned that thing.
Yeah, so that is going to bit expensive and bit slow as well. Okay, that is what we have experienced in the real-time project. That's why we use this unload. What's going to happen in the unload is, let's say you have a 4-node cluster and every node has a 2 slices. Then 8 slices of your cluster are going to work and unload the data to some S3 location. Okay, so actually you are using the proper your parallelism of the Redshift. But if you create a JDBC connection, that was not that much efficient, and it was a bit confusing as well. So this might be confusing for you right now, okay? But it's actually more faster and simpler way of doing the things.
Okay,
You are
got it.
Yeah. So what we are doing, see, let me just rephrase this for you. We have a source file S3 input path. This is where our changes are going to come. We have unload part. This is where our existing data is going to be unloaded from the Redshift table. Then we are going to compare these two data and create, take the changes and re-update them onto Redshift.
Okay, got it.
Okay, so I hope this code. Sorry, I have changed my screen. I hope this code is clear to you guys.
Also, the surrogate key, right? Suppose we can't use it in anywhere in our thing, right? Like we can't use it as a key, right? Key type of something like that, right?
Depends how you data model your things. It depends on that. Sometimes you can use that. Mostly it's not usable.
Okay. So if I want to increment my existing thing as 10, okay, like a row count of 10. So I want to create my cycle after 10 only. So those functions are available, or we need to write it on our own.
No, we have to write that our own, and we are doing it at a later stage here.
Okay, fine. Okay, okay.
Okay, then let's move ahead. Okay, so what next I'm doing? Simple things. I'm converting my data frame to dynamic frame, converting data frame to dynamic frame. Okay, I'm reading and writing into dynamic frames. This is just, not so very huge benefits or losses here to write into dynamic frames. Okay, you can read into data frame and write into data frame. That is also doable, that we have done in the AWS Glue example. Okay, that place we didn't read into dynamic frame, and all these conversions were not there. This is something I just, for learning purpose, I have mentioned it here, that how you can convert from dynamic frame to data frames. Okay, yeah. Then I am saying clean previous path. What I'm saying here is, wait a second, clean previous path before writing. What is the file path? Just a second, I also got confused here. File path variable is, yeah. So what I'm doing here, see, I am going to clean the output path. This is file path, is nothing but output path. Okay, this path I'm going to clean. Basically, let's see it by example. Let's go on S3. Clusters, this should be available now. It should be available now. It is available. Yeah, what I'm saying here is, let's go on this. This is my output path, and I'm going to remove this file first. Okay, because if I do not remove that file, and if I simply upload the new file, both the files are going to be copied onto my Redshift table that I do not want. That's why I clean the path first. I am going to write the new file on the same location. Okay, using the right dynamic frame options. Frame is going to be output that I have my dynamic frame. Connection type is S3. Location is S3 output path. Format is Parquet. Okay. Always remember, whenever you use ETL operations, write your outputs in columnar format, that is Parquet format. Okay, I'm simply using these things to write the data file on S3 buckets. A new file will arrive here. After that, I have one more target, that is Redshift table. Okay, that I would like to copy this file into a Redshift table. For that, I call my functions, from my functions, copy data Redshift. Okay, if you see in this function, I am passing 5 arguments I'm passing. Okay, that is RS schema, RS table, SC output path, and Y as a hard coded value. Okay, let's see what we have inside this copy data Redshift. This is the function, and if you see the variable names here, it is RS schema. Okay, the schema name, public. RS table, the table name, output location from where you want to copy the data, and truncate flag. So I have one more thing, that is truncate flag. Whether we want to do a truncate and load, or whether we want to do a append and load. Okay. Then, as I explained previously, creating connection with Redshift. Okay, and for that connection, we are going to use these variables. Then I'm creating my SQL copy query. Okay, I'm simply creating my query. And as we have seen this thing already in Redshift examples, if I open that thing, DDL, Redshift, DDL, here we have a copy example. Okay. So what we have in copy, we have table name. Same thing we have here, copy schema name dot table name. Okay, you can mention schema and or table both names, and we are mentioning both here. Then what you have, then you have from, and obviously your path is going to be variable. That's why I have from statement and the output path that I have used to write the file, that is eventually this path is my source path now. Okay, IAM role, which IAM role has the access that it needs, and then format is Parquet. Comp update is false. That means you do not want to calculate any encodings on the fly. And set update is true. If there's any unsorted rows, unclaimed path, unclaimed space that we have discussed uh, in the Redshift classes, those things, this is those settings. Max error, I am keeping it 0. And all these three things are completely optional. OK, these are completely optional for this copy command. So like this, I'm preparing my copy command. Again, remember, I'm telling you again, this SQL copy is nothing but a Python string type variable. Till now, at this point, it is nothing more than that. OK, but then we are having one more query, that is SQL truncate query. In this, I say truncate space schema name dot table name. OK, then I have a condition. Then I have a condition if truncate flag equals to y. See, in production or in real times, you have variety of approaches, like whether you want to simply appending the data, like I'm receiving the data today, and I would like to clean my table and append all the data as it is. That is one approach. You do not want to delete the data and you simply want to keep appending that data. That is the second approach. And you want to delete only specific data, and then you want to append the data. So we have three approaches. So for out of these three, we are covering two here in this function. The third one is covered in another function. OK, so what we are saying here, if truncate flag is equals to y, that means the value that we are receiving in this truncate flag, that is y here. Okay, we are passing y here. Truncate flag is equals to be y. So what we are going to say, we are going to say begin. That means we are going to start our query. In the first place, we are moving truncate query. Okay, we are pasting truncate query here. Then in second place, we are pasting copy query here. So what's going to happen? First of all, my table is going to get truncated, and then it's going to run the copy command to load the data from its output location into Redshift table. OK, if we have anything else than y here in the truncate flag argument, then I am simply preparing my query with SQL copy only. I have only one variable here, and I'm preparing that query. I am not going to run my truncate query, and I'm not going to delete any data from my table. OK, for reference how it's going to look like in the actual, I am printing my SQL command. And at the end, on line number 40, eventually I am going to execute that statement. Run SQL is my final statement. It is not SQL copy. It is not SQL truncate. Run SQL is my final SQL statement that I'm going to execute here in the SQL. OK, this execute statement is same that we have discussed in the previous class, and its functions also are same. Here I have simply used a different approach. I have called a function called check query status. OK, earlier if you see in the unload data Redshift, where it is, yeah. If you see here, this while loop I have kept directly in the sequence, but here in the copy to the Redshift, I have simply moved it to another function called check query status. So do not get confused here. It's doing same thing. That is, it is waiting for Redshift to complete its query execution. OK, so my control after executing line number 40, that is execute statement, is going to come and go in check query status. And in check query status, I am simply checking my query status. Okay, using an infinite while loop and waiting till my query is finished or successfully finished or failed. Okay, so I'll keep you guys here for, I'll pause here. If you have any questions, please let me know.
Regarding the status, right? So whatever we see in CloudWatch, right, that will be displayed there, like succeeded or failed.
Yes, it will be.
Okay. So those commands are Python commands only, right? Boto commands, right?
Yeah, those are Python commands only.
Okay.
Okay, so we have any questions?
No problem.
Okay, so let's run this. Let's come on the cluster in the query editor. Let's verify a few things. I haven't executed this code in the last 3 months. So let's verify a few things. Airbnb price details. We have this table. It is in same structure, surrogate key, new price, load time, active indicator, correct. Then let's go on AWS Glue. Guys, it's been more than 2 months this course has started, so I don't think that you will have a free trial access on Redshift. So make sure to pause and restart the cluster for your practice, okay? Do not keep it open. So here our job name is project hands-ons. Here, if I try to find Python 2, we have nothing. Correct? Okay. Last thing. In this, we need Airbnb. This is my source location. Okay. And if I am not wrong, Airbnb price 66 KB. This is the file that we right now have here. Okay. This is the exact file that we have here. And let's check one more thing in the Redshift. I always like to keep it like this. If I say preview data here, we should not have anything here because we are attempting a first time load. Unfortunately, we do have data, so let's do it like. So what is the maximum value here that we have? How come? I'm running it manually for just once. Airbnb. This is done. Let's say preview data one more time. This is weird. Let's say public dot. I do data. I think it is cached. Let's refresh this. So if this happens to you, Redshift might be caching the data. So let's. It is refreshed. We are connected. Refresh the resources. Airbnb price details, preview data. We have nothing this time. Okay, so yeah, everything is all set. We have input file here. This is first time upload that we are doing. Then we have a script. Let's execute this script manually right now. We will trigger it by Lambda functions in the later stage. In the job details, in the runs, actually, you will get the run details. It is running right now. So let's go into the logs. Output logs you want to be. And if it fails with syntax error, please go in error logs. And let's hope it does not fail now. For better clarity, say view in columns with details. Resume this and just hold on. So in this case, status of the that query ID is finished. It is coming from the unloaded Redshift. It is this line it has executed. So my query of unloading data was successful, and as we have noted it there, that's why it got finished very quickly. We are successful, and you can see the previous data frame length is 0 only. Okay, and it says no data found at the previous location. And the final result that we got after the surrogate key generation, we have count of 1499. This is the same count that we have in this file, and if you check it here, it's 1500, and first row is header only. So we have 1499 count. This is the schema that we have generated: listing IDs, price, neighborhood full, surrogate key, load time, and active indicator. This is the sample data I am printing here. Okay, if you want to get this on Notepad, simply say copy. This is actually very important thing when you're actually going to work now. This is going to help you. Just paste this, and you can see, not the complete data has been pasted here. Don't do anything here. Do not move your cursor. Come down, click on next copy, and say paste. It's going to be all good. Okay, so this is your sample data. And then this is a SQL command that we have generated. So it is from copy data Redshift. So if I go back to my code, copy data Redshift. This is the function, and at the end I say print SQL, run SQL. So if as we have passed y for this case. As we have passed y for this case, okay, this is the command that we have generated, begin. Then my truncate command, that's simply the one I used previously. Then my copy command. It is there with correct location, correct IAM role, and correct table name. And at the end we say data load for this table is finished. Okay. And it also says no entry is made in DynamoDB. This is something we will discuss on the final stage. And if I come back here, if I say preview data now I should have data here. Okay, this is actually querying, caching the data. So let's, instead of doing that, let's say select star from this table and execute this query. And we do have data here. And surrogate key is 1499 for the highest one. Okay, and as you can see, the price column is like this and new price column is like this. So this is the half code. I mean, 40%, or you can say 30% of code is done. If you have any questions, you can let me know. Rest part we are going to cover in this, next classes. But please, guys, make sure to join because I do not want any gaps now. Yes, open for questions now.
Oh, Jalaj, can you show that result? Okay, here, right? New price and price. So in general, the price will be removed, right? Only the new column will be.
But if you see my with column statement, I never said to remove it. I'm creating a new price column. I'm not saying price here.
Okay. In that case, right? In general, normal SCD type 2 will be having a start date and end date, right? So how? So we'll be handling those stuffs also.
See, we already have the kind of start date or load time here. Okay. I'm calling a load time here. We can create two date columns. So what you're going to do here is, like, you are going to have two columns here. One is load time, or you can call it start time, and then you're going to have one more update time as well.
Yeah, I understand this one. See, suppose you have an active indicator. So now for now, all the records will be Y only, right?
No, I'm not saying active indicator. I'm saying something like this you will do.
Yeah, that's understand load time. That's fine actually. I'm just asking for the load indicator actually. So suppose you, this is to state, right? Whether the particular record is an old record or new record. So active record means it's a new Y means it indicates a new record. If it's going to be delete or a kind of thing means it's a old record, right? So how do in this query, right? Can you do like that? It's a old record and new record.
We are doing all those things here. We are doing all those things here.
Okay. So
actually, if statement, if you see, if statement is very straightforward, it's just kind of this much code only. But if you see else statement, we are having variety of conditions. Finding new records, finding dropped records, finding updated records, all those things are actually here.
Oh, this much code we need to write for it. Oh.
Yeah, this much code is actually still pending.
Okay. Okay. Yeah, today we'll be sharing this code, right? Or
let's just wait for one more day.
Okay.
Okay, so actually tomorrow I'm just going to focus, on these code changes. I'm not going to go through that my functions page again. Okay. Prepare for that. Okay, please go through the two recordings that we have for this project and let me know if you have questions. I hope. Oh, Ashwarya is not there. Okay. I hope I'm clarifying all the questions. Okay. Thank you, guys.
Yeah. Thanks.